Hey everyone, it's Justin again. In this lesson, we're going to write equations of parallel and perpendicular lines. We'll complete 2 example problems together, and then you'll get to practice a few more in your PDF. The great thing about this lesson is that there's nothing new to teach you. You already have all the knowledge you need to write equations of parallel and perpendicular lines. I just get to help you apply all that knowledge together. So since we're going to be writing our own equations, we need to remember some very important information about the different forms available to use. We have slope-intercept form as an option. What information do we need to write an equation in this form? Yep, we need the slope and the y-intercept. We'll definitely want to keep this form in mind as the best option for writing an equation when we know those 2 things. Then, there's point-slope form. Do you remember what information we need to make this form? We need the slope, and we need any point on the line. Now, do you remember what the other form of a linear equation is? It's standard form. What information do we need to write the standard form of a line? Yep, this form doesn't come from any direct information about the line itself. So this form won't be used in this lesson, but it will come back in the next lesson, so definitely don't forget about it for then. So here are the 2 forms we'll be focusing on when we write our own equations for parallel and perpendicular lines. Let's keep these in mind as we reason through 2 example problems together. This problem says, what is the equation of a line parallel to the line y equals 2x plus 5 that goes through the point 0, 3? Well, let's think back to what we just talked about. To come up with an equation, we need 2 pieces of information. We need the slope, no matter which of these equation forms we're going to use, and we need a point on the line, which more specifically could be the y-intercept. So can we find those 2 things given the information in the question? We can. The slope has to be parallel to this line. Do you see what the slope of the given line is? What would be parallel to that? The slope of this given line is 2. And we learned in the previous lesson that parallel slopes will match, meaning a parallel line will also have a slope of 2. Now, remember the other piece of information we need to write an equation. We need a point on the line, which could more specifically be the y-intercept. Do we have that information? Yeah, it's right here. Is this any point on the line? Or more specifically, is it the y-intercept? Since the x value is 0, this is the y-intercept. So which of these equation forms should we write our equation in? We really could use either form here, so let's explore both of them to see which one we like best. Go ahead and substitute the information we have into both slope-intercept and point-slope form to write the equation both ways. Pause the video so you have some time to do this yourself. Substituting the slope and y-intercept into the slope-intercept form gives us y equals 2x plus 3. And substituting the same information into point-slope form gives us y minus 3 equals 2 times x minus 0. Now, both of these are correct, but which do you think is an easier form to interpret? Yeah, definitely slope-intercept form. With standard form, we have this minus 0 that can be confusing to people. When we have a situation with a 0 in point-slope form, let's just go ahead and change it to slope-intercept form. If we take that 0 away, then we can also get rid of the parenthesis, and then get y by itself. And there we have it. It's the same slope-intercept form equation that we already had. Slope-intercept form will look nicer than having a 0 in point-slope form, so let's go with that instead. Here's another example to try. This one says, What is the equation of a line perpendicular to the line y minus 4 equals 5 times x minus 3 that goes through the point 1 comma negative 2? I'd like you to give this one a try on your own. Remember the things we need in order to write the equation in either of these forms. Pause the video and try this one now. Figuring out the slope isn't quite as straightforward this time. We know that we need a slope perpendicular to the slope of this line. So what is the slope of this line? Yeah, the slope of this given line is 5. So what is the slope perpendicular to 5? A perpendicular slope will be the opposite reciprocal. Let's write 5 as a fraction. Then, to get the reciprocal, we switch the numerator and denominator, and since we want the opposite reciprocal, we also need to change the sign from positive to negative. Now that we have the slope for our new line, what else do we need? We either need the y-intercept or any other point on the line, which we have right here. This is a point on the line, but it's not the y-intercept because the x value is not 0. So, which of these forms is going to be our best option for writing an equation given the information we have? Well, we don't have the y-intercept, so slope-intercept form is not the ideal option. But point-slope form should work very well. If you weren't able to get this far earlier, pause the video and substitute the slope and point into this equation form. Double check what you have with this. We can leave the equation in this form this time. There isn't an extra 0 in the equation like we had in the first example problem, and there are no directions telling us to write our answer a certain way, so this is totally fine. Now you can write equations of parallel and perpendicular lines. Remember to choose the equation you substitute into based on if you have the y-intercept or just any other point on the line. And also, although substituting into point-slope form is correct, if you have a 0 somewhere, it'll look a lot nicer to change the equation into slope-intercept form instead. Once you finish your notes in your PDF, be sure to complete the additional practice and then check in with an adult and the key. You'll see another example where there's a 0 involved, and you'll start with point-slope form and then change the equation into slope-intercept form. So be sure to work through that before you start the practice game. See you next time! Hey.